The science behind the floating of hot air balloons is rooted in the principles of buoyancy and the behavior of gases, particularly the relationship between temperature, density, and volume. Hot air balloons operate on the basic concept that warm air is lighter than cold air, causing the balloon to rise when the air inside is heated. Here's a breakdown of the science behind hot air balloons. 1. Buoyancy. Buoyancy is the upward force exerted by a fluid, in this case, the air, on an object immersed in it. When an object is less dense than the fluid, it experiences a buoyant force pushing it upward. This principle is fundamental to the operation of hot air balloons. 2. Relationship between temperature and density. The density of a gas is inversely proportional to its temperature. When air is heated, its molecules gain energy and move more rapidly, causing them to spread out. As a result, the air becomes less dense. Conversely, when air cools, its molecules lose energy, move more slowly, and become more densely packed. 3. Charles's law. Charles's law describes the relationship between the volume and temperature of a gas, stating that the volume of a gas is directly proportional to its temperature if pressure remains constant. In the case of hot air balloons, heating the air inside the balloon increases its volume, making it less dense than the surrounding cooler air. 4. The balloon envelope. Hot air balloons consist of a large, lightweight envelope, typically made of nylon or polyester, that is filled with hot air. The envelope traps the heated air and becomes buoyant, causing the entire balloon system to rise. 5. Burners. The burners, mounted at the base of the balloon, are responsible for heating the air inside the envelope. They generate a flame by burning propane, producing a significant amount of heat. The hot air rises and fills the envelope, creating the buoyant force required for the balloon to ascend. 6. Controlling altitude. Controlling the altitude of a hot air balloon involves managing the temperature of the air inside the envelope. To descend, the pilot can allow the air inside to cool gradually, increasing its density and causing the balloon to descend. To ascend, the burners are used to heat the air, decreasing its density and lifting the balloon. 7. Ambient air temperature. The ambient air temperature also plays a role in the flight of hot air balloons. Since the balloon rises when the air inside is warmer than the surrounding air, pilots often consider the temperature gradient at different altitudes to plan and control their ascent or descent. In summary, the science behind hot air balloons is grounded in the principles of buoyancy, gas behavior, and the relationship between temperature, density, and volume. By heating the air inside the balloon envelope, pilots create a buoyant force that allows the balloon to float and rise into the sky. The control of altitude is achieved by adjusting the temperature of the air inside, providing a simple and elegant application of fundamental principles of physics.